on Monday night, killing at least 7 people and injuring dozens more. Witnesses said 2 missiles hit the city center within
function. First one is the natural grazing. They are going to consume biomass and therefore they are going to reduce the fire risk. Secondly, is a species that is endangered.
This is a land of extremes, where a herd survival can only be assured by a strong and worthy.
For decades, one stretch of land in northern China held nothing. No grass, no shrubs, no visible life. Scientists had studied it, mapped it, and largely written it off, another casualty of desertification eating away at Asia's grasslands. No irrigation project, no reforestation campaign. Nothing had managed to reverse it. Then, in a decision that puzzled even some of the researchers involved, Chinese conservation teams did something that seemed almost irrational. They released horses into it. Not machinery, not seeds, not chemical soil treatments. Horses, descendants of one of the last truly wild horse populations left on Earth, a species that had once vanished entirely from the wild, existing only behind fences in zoos and breeding centers. The animals were set loose onto ground that, by every conventional measure, could not support them. Little to graze, little to drink. But something began to shift, slowly, quietly, in ways that did not show up in the first weeks, or even the first year. What researchers eventually documented raised a question that reached far beyond one patch of desert. Had they been fighting desertification with the wrong tools all along? The land was not supposed to change, but it did, and nobody fully agrees on why. The animals at the center of this story are Przewalski's horses, the only surviving truly wild horse species, genetically distinct from domesticated horses. By the 1960s, they were extinct in the wild, surviving only in zoos and breeding facilities descended from a small founder population. Starting in the late 20th and early 21st centuries, conservation programs began reintroducing captive-bred horses into their historical range, including China's Kalamili Nature Reserve. China has separately invested heavily in combating desertification, including large-scale afforestation projects like the Great Green Wall Initiative. Ecologists continue to debate how large grazing animals affect arid ecosystems. Some research suggests grazing, trampling, and manure deposition can help break up soil crusts, disperse seeds, and cycle nutrients. Other researchers caution that in already degraded regions, large herbivores can worsen soil compaction rather than help it. Some popular science framing extends these findings to argue herbivores could reverse desertification at a continental scale. This remains a hypothesis actively tested in limited pilot regions, not an established universal solution. The anomaly researchers faced was straightforward on its surface and deeply strange underneath it. Land with almost no vegetation should not, in theory, support grazing animals for long. Yet monitoring teams tracking the released horses noted survival rates that defied the pessimistic models drawn up before release. More curious still, vegetation surveys in the years following began showing patchy, localized increases in plant cover, areas that had shown no such recovery before. The obvious question followed, were the horses actually causing this, or was it coincidental with rainfall, wind patterns, or other conservation work nearby? Correlation is not causation. Separating the horse's effect from background noise became the central challenge.
To untangle cause from coincidence, teams turned to systematic monitoring, soil sampling before and after grazing periods, seed dispersal tracking through manure analysis, comparative plots, areas with horses versus fenced-off control areas without them. Some rewilding studies have also incorporated AI-assisted satellite image analysis to detect small-scale vegetation changes across large desert areas. It's worth being precise about what AI actually contributes here. Machine learning can process years of imagery to detect subtle vegetation shifts far faster than manual review, flagging correlations between animal movement and land recovery. What AI cannot do is establish biological causation alone or confirm why something is happening. That still requires field scientists interpreting data. The combined data pointed toward an herbivore-driven mechanism, hooves breaking hardened soil crusts, manure acting as fertilizer and seed transport. As findings circulated, disagreement emerged, not over whether recovery occurred, but how significant and replicable it truly was. Some ecologists warn that small pilot areas often show promising results that fail to scale across harsher landscapes. Others questioned whether water availability, not horse activity, was the real driver of any recovery observed. There is no confirmed evidence of any institutional cover-up in this case. Conservation programs are often cautious about publicizing early results before long-term data confirms them, caution sometimes mistaken for secrecy. Any vegetation recovery is primarily attributable to natural climate variability, increased rainfall, with horses playing a minor supporting role. The horses' grazing and manure meaningfully altered soil structure, a genuine ecological catalyst that could scale to other degraded regions. The changes are too localized and early to generalize. Long-term controlled studies are required before any broader conclusion. Each interpretation currently has scientific defenders, and no consensus fully resolves the debate. There is something quietly humbling in this story, regardless of which explanation eventually holds up. For all of humanity's engineering, one of the most promising signals may have come from an animal doing exactly what it has done for tens of thousands of years. The Przewalski's horse vanished entirely from the wild because of human expansion, now potentially undoing some of the damage that expansion caused elsewhere. Solutions to ecological damage may not always look like new technology. Sometimes they look like giving something old the room to do what it always did. Researchers continue monitoring the site today, gathering more seasons of data before drawing firmer conclusions. The desert has not become a grassland. It has not been solved, but something changed where nothing was expected to. If a handful of horses, left alone and bearing ground, could nudge an ecosystem back toward life, what else have we written off as unsavable? What do you think actually changed that land? The horses, the rain, or something science hasn't fully measured yet? Leave your theory in the comments below.